All right, today, how do you construct parallel lines in GeoGebra? Well, first, you need a line. So let's go to line tools. We're going to do line AB. If I were you, I would put A and B a little bit closer together. I'll show you why in a little bit. And then usually they're like, construct a parallel line through a random point. So let's put our random point C on our page. All right, first things first. We need to take a line and put it through A and our random point. So now here's the deal. If you know the converse of the corresponding angles postulate, then you know that if I can copy this angle right here, angle CAB, and I can copy that same angle up here, then I can create parallel lines, because if those two angles are congruent, then lines are parallel. So let's do this. So we're going to come over here. We're going to hit more. We're going to scroll down till we find compass. And we are going to create a circle with a radius of AB. And we're going to center it on A. Now I'm going to copy that same exact circle. So I'm going to do the same thing. So I have my compass. I hit A, B. And this time I'm going to center it on C. So now check this out. The distance between A and this intersection is the exact same length as the distance between C and this intersection. So let's put 2 points there to make sure we know that they are important and we can use them later on. All right, now if you remember from copying an angle, if I can measure this distance between B and D using my compass, and make that same exact distance between E and some sort of intersection on this circle, then I can connect that intersection to C, and it should make a congruent angle, which would lead to parallel lines. All right, so let's go down. Let's grab our compass again, and we're going to measure the distance between B and D. So see how that's now the radius of this circle, right? That length. So we're going to come up here and we're going to put that length on E. Boom. This intersection right here is important. It has the same distance. So according to the copying and angle construction, ECF is going to be congruent to DAB. So that means that corresponding angles are congruent, therefore lines are parallel. So let's make that line. So we're going to draw a line between C and F. Well, they look parallel. We never want to assume. So there's 2 ways that we could prove it. One would be measuring our angles. We have angle ECF, which is now 62 3/10. And we have DAB, which is also 62 3/10. Our angles are congruent, therefore our lines are parallel. Another tricky way that you could do this with GeoGebra is see this construct parallel line. We could check it that way. When you click this, it tells you select a point and a parallel line. So select your point we started with, C, and then select the line that we started with, which was line AB. If I do this, it should give me a line that's directly over CF. So let's see. Boom! You see how no extra lines showed up, but CF is a little bit thicker, a little bit darker. So we know that it landed exactly where it was supposed to be. So I hope yours did the exact same thing. If not, rewatch, follow through the steps slowly. Nice job.